All right, so let's talk about what happens when we see discontinuities in the graph of the derivative. So here I've got a graph of a derivative, and it does its thing, and then all of a sudden it jumps down to here. And then it does its thing, and then all of a sudden it jumps down to here, and then it stays constant for a while, and then it ends. And my x-axis is right here, and it doesn't really matter where my y-axis is for the purposes of this discussion. So let's call this 1, and let's call this 2. And here's what I see at 1. I have a positive slope. Oh, I don't know if you guys know this notation. Positive means positive, and negative, negative. This is, I don't know who uses it. I've been using it for years from engineering, physics, science, I don't know. Anyway, jumps from positive to negative. Well, how do you jump from positive to negative? And notice that the derivative does not exist at that point. Well, this must be some kind of corner. There's a positive slope. You know what? Let's do this. Let's be all official and write f prime greater than 0. And here's a negative slope, f prime less than 0. It can't be a maximum because it's not really giving you there's no critical point there. You can't take the derivative at that point and say, oh, look, there's the derivative equal to 0. So it can't be a smooth curve. It's got to be a corner right there. So we see a corner right there. And again, looking at the next one, we do the same thing. We have a positive derivative here, f prime greater than 0. Down here, we have f prime less than 0, which means, once again, we were going up, and then suddenly we're going down. So what must this graph look like? Well, if I'm going to redraw it. I'm going to redraw because I want, again, more room. Those of you who watched my last video and saw me get in trouble with my space, so what I notice here is that I'm going up, but I'm going up at a stupid computer. Going up at a decreasing rate, and then I reach a maximum and I start coming down, and then I reach a minimum and I start going up, and then I reach a corner. And I start going down, and I go down till here, which means that, again, I have some kind of minimum. And I start to go back up again, and I reach another corner, but notice that I now have a constant negative slope at that corner. So perhaps my graph looks something like this. I've got a corner here, I've got a local maximum, a local minimum, I've got another local minimum here, I've got another corner here, and then my graph ends. So that's one possibility. And notice, again, horizontal line, constant decrease. I just throw that in because, why not? Good reminder. So why don't you do exercises 47 and 51 and see if you can come up with the graphs of the functions with jumps. And just remember that a jump discontinuity on a derivative graph implies a corner. All right, and I'm going to stop this video here, short video, but the last video is the recap, and we don't really have anything else to talk about in this chapter, so we'll see you then. Well, we would see you then if my stylus didn't stop working and have to be reset.